everyone and welcome to my channel. So today we have a question which was asked in the IIT Joint Admission Test for Masters, that is the JAM entrance examination. And the question says the correct statements about the octahedral manganese complex with spin-only magnetic moment of approximately 6 Bohr magnetons. And in the options we have to predict the possible oxidation state of manganese and whether the ligands which are associated with this complex are weak field or strong field. So we have only the spin only magnetic moment value. Okay, so you very well know that mu spin only formula. Okay, so the mu spin only formula is under root of n into n plus 2, where n is what? You very well know this formula, and n is the number of unpaired electrons. Okay, and this mu s has been given to us as 6. Okay, the n into n plus 2 value is 36. And from here we have to predict the value of n. So what should be the value of n if n into n plus 2 is 36? So if we have 5 as n and then 5 plus 2. So we have 7 5s are 35. So that means this number of unpaired electrons is approximately somewhere equal to 5, around 5. So you can note here in the question that it is given the approximate value of the spin only magnetic moment is 6. Okay, so approximately 6 means the square root of 35 is around 5.9, and that is an approximate value, and we have n equal to 5. Now if n is equal to 5, that means what should be the valence electronic configuration? Now we know that in this complex manganese is in the +2 oxidation state. So for n equal to 5, we have manganese in the ground state. What is the valence electronic configuration? We have 3d5 and 4s2. Now in order to have only 5 unpaired electrons, that means these 4s electrons are gone. And when these 4s electrons are gone, then we have only 3d5. Okay, 3d5 configuration. And when these 4s electrons are gone, that means the manganese is now in the +2 oxidation state. That's because it loses 2 electrons, 2 4s electrons it loses, and then it is in the +2 oxidation state. And manganese in the +2 oxidation state will have 3d5 4s0. And now in order to get these unpaired electrons equal to 5, we know from the spin only formula that in this complex, in this manganese complex, the number of unpaired electrons are 5. That means if the 3d electrons are not paired, okay, 3d 4s. Now if we want to see how we fill these electrons, so we have 3d5, 1 2 3 4 and 5, and all of these 5 electrons are unpaired. Okay, this we know from the magnetic moment spin only formula, which gives us n equal to 5, number of unpaired electrons equal to 5. Okay, that means these 5 electrons are unpaired, and for these 5 electrons to be unpaired, the ligands, okay, the ligands in this complex should be weak field ligands. Okay, why weak field ligands? Because in general we know very well from our coordination chemistry knowledge that weak field ligands do not support pairing. So whenever there is a weak field ligand which is attached to the central metal atom, then it will not pair, it will not favor pairing. So there is no pairing of the d electrons if the weak field ligands are coordinated to the central metal atom. So you can see here very well that from only this magnetic moment spin only formula, we can predict the oxidation state as well as the nature of the ligands of a particular complex. So we got how many number of unpaired electrons? We got 5 number of unpaired electrons from a value of mu spin only, that is equal to 6, that was given in the question. And when we know that there are 5 unpaired electrons in manganese complex, that means the oxidation state becomes 3d5 4s0. And when 2 electrons are gone, then we have only d5 electrons. Okay. And now, in order for these d5 electrons to remain unpaired, we need a ligand or number of ligands which are weak field ligands because they do not favor pairing. So, the nature of the ligand can also be predicted, that we have predicted as the weak field ligand. So, that gives us the answer to this particular question. So we have option B where it is said that possible oxidation state of manganese in this complex is +2. This one is correct. And the ligands associated with the complex is weak field ligand. This one is also correct for this manganese complex. So option B and option D should be our correct answer for this complex. So I hope you understood the explanation for this question, and if you have any doubts, please write to me in the comment section. And please do like, share and subscribe if my videos are helpful to you. Till then, thanks for watching and see you soon.